Good morning, good afternoon, whichever one it might be for you. Hope you guys are having a good day. I'm going to run through this lesson with you, 2.7, solving equations in one variable. So it'll be pretty quick, maybe 10-15 minutes, and then Mr. Day will pass out your homework and you can work on that for the rest of class. So I went out and printed out a worksheet for you. It's not very pretty, but better than nothing. So here we go, solving equations in one variable. We're going to solve rational equations. We're going to talk about something called extraneous solutions. And we're probably not going to get to applying solutions to real world applications today. We'll look at that tomorrow when I return. All right, so here we go. Solving rational equations. Equations involving rational expressions or fractions are written in the form f of x over g of x equals 0. So if f of x and g of x are polynomial functions with no common factors, then the zeros of f of x are the zeros of the solution. So basically what that's saying is we just set the numerator equal to 0, and that's how we solve for our zeros, but that's only if we have one term f of x over g of x. So when we multiply or divide an equation by an expression containing variables, the resulting equation may have solutions that are not solutions to the original equation. These are extraneous solutions. So we'll go ahead and talk more about what that means. So here is the first example. We have x plus 3 over x equals 4. So the first thing we have to do when we see a problem like this is we have addition over here, but unfortunately we do not have a common denominator. So the way we're going to resolve that is by multiplying this left term only by x over x. Because x over x is just 1, and you can multiply anything by 1 and it'll stay the same. So what we're going to get now is x squared over x plus 3 over x equals 4. Alright, and to make things even simpler, I can even multiply by 4 by x over x as well. So it has the common denominator. So I'd get x squared over x plus 3 over x plus 4x over x. I'm sorry, that's equals 4x over x. So now we have one denominator, and I'm going to subtract 4x here. So I'd get x squared minus 4x plus 3 over x equals 0. So once I'm here, okay, once I have one term over my denominator, I can just eliminate the denominator because all I need to do is set the numerator equal to 0. Alright, if I really wanted to, I could multiply by x. You can think of it like that. And so that would get rid of this. And then I'm just left with x squared minus 4x plus 3 equals 0. So from here, I would just have to factor. So I'm going to do the ACB method. A times C is 3, B is negative 4. So I want two values that multiply to positive 3, add up to negative 4. Those would be negative 3 and negative 1. So I'd get x minus 3, x minus 1. So my solutions would be x equals 3, because remember this is equal to 0. X equals 3 and 1. So those are my solutions. So before I can call it quits, I have to go back to my original and plug both of those in here and make sure I don't get any zeros in my denominator. Okay, so I plug in 3, I'd get 3 plus 3 over 3. 3 plus 1 equals 4, that's true. Okay, I'm going to try 1. 1 plus 3 over 1 is 1 plus 3 is 4. So we're good. We didn't have any extraneous solutions. So my answers are x equals 3 and x equals 1. So ultimately, what I'm doing with this first step is just finding my least common denominator. So I want to find an LCD. The one before here, my LCD was x. Okay? So really, basically all I did was multiply the entire thing by x. So here, my LCD, over here I have 1, here I have 1. So clearly my least common denominator is going to be x minus 4. So that's all there is. So what I'm going to do is multiply this entire rational equation by x minus 4 over 1. So I'm going to multiply the entire thing by the LCD. So what I'm going to get is x times x minus 4 plus 1 times x minus 4 over x minus 4 equals 0 times x minus 4. And you'll see what happens here is I have x minus 4 in my numerator, x minus 4 in my denominator. They can cancel. 0 times anything, 0. So now all I have to do is work this out in here. So I'd get x squared minus 4x, just distributing, plus 1 equals 0. And now again, I have to try and see if this can factor. So looking at ACB, AC is 1, B is negative 4. I cannot think of anything that is going to multiply to 1 and add up to negative 4. So chances are here I'm going to have to do the quadratic formula. So remember, that's x equals negative b plus or minus radical b squared minus 4ac all over 2a. And this is coming from ax squared plus bx plus c. So I'm going to get x equals negative b, so positive 4, plus or minus the square root of 4 squared minus 4 times a times c all over 2a, which is just 2 times 1. So we can simplify this a little bit. 4 plus or minus the square root of 16 minus 4 over 2. And once again, 4 plus or minus root 12 over 2. And then 12 here I can simplify, because that 12 is really 4 times 3. So I can make that 2 root 3. All right? So I get 4 plus or minus 2 root 3 over 2. And now I can cancel that 2 out because I have a factor or a multiple of 2 in both the parts of the numerator. So you always have to draw the hard. Okay? It has to cancel from both here and here. It can't just cancel out of the 4. It can't just cancel out of the 2. All right? So 4 over 2 is 2, plus or minus 2 over 2 is just 1. So I'd get 2 plus or minus root 3 would be my solutions. And if I go back and plug that into my original, 2 plus or minus root 3, neither of those are going to give me a 0 in the denominator, so I'm not going to have any extraneous solutions. So that would be my answer. All right. So now we're going to take it one step further and see here we don't have just one value that's going to be my LCD. I have x, I have x plus 2, and I have x squared plus 2x. But lucky for us, those things all are related to one another. Okay? It just so happens that x times x plus 2 equals x squared plus 2x. That's a theme you're going to see over and over and over again, that two of the denominators, when you multiply them, give you the third. All right? So that's something that's going to happen often. So I have my least common denominator is obviously has to be the biggest one. So it would be x times x plus 2 or x squared plus 2x. Those two are equal. All right, so I'm going to multiply the entire thing by x times x plus 2. All right, so what I'm going to get is x times x plus 2 times x minus 3 over x plus 3 times x plus 2 over x plus 2 plus 6 x plus 2, which remember really equals x squared plus 2x over x squared plus 2x equals 0. Anything times 0 is 0. Okay, so once I'm here, I can go through and cancel out some stuff. So x is canceled, x plus 2 cancels, and everything cancels here because x times x plus 2 is x squared plus 2x. So what I'm left with is x plus 2 times x minus 3 plus 3x plus 6 equals 0. Alright, so I'm going to multiply this business out here, foiling, so I get x squared minus 3x plus 2x minus 6 plus 3x plus 6 equals 0. Looks like I'm going to get some stuff to cancel. My minus 3x plus 3x minus 6 plus 6. So I get x squared plus 2x equals 0. Alright, and we see from there I can factor out an x. So I'm left with x plus 2. Set both equal to 0. I get x equals 0. And x equals negative 2. Here's my solutions. Now, as it says there, I need to go back and check and see if those will work. Okay? So I plug in 0 in my original function right off the bat. Can I have a 0 here? Absolutely not. You can't divide by 0, so that's not a solution. I check negative 2. Look at this. Negative 2 here is going to give me a 0 in the denominator, so that's not a solution. So both of these here are what we call extraneous solutions, or extraneous roots. Extraneous, maybe. So the final answer here would be no solution. Alright, so we did all that work for nothing, basically. Except to find that it didn't have the solution. Alright? So again here, with this last problem, we have x minus 1 times x minus 3. And that's going to give us x squared minus 4x plus 3. If you don't believe me, we can work it out. X minus 3, x minus 1. You get x squared minus x minus 3x plus 3. X squared minus 4x plus 3, which is what we have right there. That's going to happen time and time again. Okay? You will see that occur over and over again. Alright, so why don't you guys take a couple minutes and try this one on your own. Mr. Day can just pause the video real quick, or someone can jump up and pause it. And then you can check your solution with mine. Alright, so as I said before, the LCD is just those being the two denominators being multiplied by one another, or really that's the same thing as x squared minus 4x plus 3, as I just showed. Okay, so I'm going to multiply the entire rational equation by x minus 1, x minus 3. Alright, so I'm going to work it out nice and slow. You guys don't have to do this every time, but I'm doing it. So 2x, x minus 1, x minus 3, plus 1, x minus 1, x minus 3, equals 2, x minus 1, x minus 3. This is over x minus 1, over x minus 3, over x squared minus 4x plus 3, which is really the same thing as x minus 1, x minus 3. So now I go through and cancel everything I can. X minus 1 cancels x minus 1, x minus 3 cancels x minus 3, x minus 3 and x minus 1 both cancel. Alright, so I'm left with 2x times x minus 3 equals x, not equals, plus x minus 1 equals 2. Alright, so I'll distribute this 2x here. So I get 2x squared minus 6x plus x minus 1. Subtract 2 equals 0. So I'll combine my like terms. 2x squared minus 5x minus 3 equals 0. So now I have something that hopefully can be factored. I'll try it out in my ACB method. AC is negative 6, B is negative 5. So two things that multiply to negative 6 add up to negative 5. That looks like it's going to work with us with negative 6 and 1. So I have 2x squared minus 6x plus x minus 3. Next step would just be to factor by grouping. So I can take out a 2x from here, x minus 3. Take out a positive 1 from here because I already have x minus 3. So I'm left with 2x plus 1, x minus 3. So I can set each of those equal to 0. And I'd get 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1 half, and x minus 3 equals 0, x equals 3. And now with these two solutions, I just want to go back to my original and check and see if I'm going to get any zeros in my denominator. So negative 1 half, not going to happen here, not going to happen here, not going to have any issues there. 3, however, 3 minus 3 is 0, so this is going to give me a problem. So that tells me that this here is extraneous. Okay? So my only solution then would be x equals negative 1 half. Alright, hopefully this all made sense to you. Remember, the first step really is just to multiply everything by that least common denominator. Then cancel out everything you can cancel, and then you just solve. Alright, so Mr. Day will pass out your guys' homework for you on the worksheet. Like I said, hopefully this was helpful and you guys can figure it out. And I'm sure if you have any questions, Mr. Day will be more than happy to help. Alright, so have a great day.